So suppose you were given a polynomial function, and we need to determine the range, the domain, and the open intervals over which this function is increasing or decreasing. Okay? We're going to be talking about these polynomial functions and the power functions that they're connected to get an idea about their shape and their location so that we can answer these questions. Now, first of all, let's get rid of the easy guy here, and that's the domain. So anytime you're talking about a polynomial function, the domain is going to be all real numbers. There's never going to be a value that interrupts what's going on here. What about your range? Well, I think for this one, it's a good idea to draw a quick sketch of what's going on. Since this has an even power, that means it's going to be akin to a parabola. So it's going to have a U shape to it, okay? And what are we doing with this? Well, this says that we're going to go to the left 5 and down 7. So over here to the side, I'm just going to do a quick sketch of this. So remember, inside you shift to the opposite side, so that's going to be -5. And then outside you do exactly what you see, so that's -7. So here's your key point. And since this is even, it's going to take on a parabolic shape-ish. Now, had there been a negative in front, it would have been the same kind of shape, but just turning upside down. So using the shape, it's very easy for us to come up with our range. So the range is a set of y values going bottom to top. So the lowest we get here is -7. So that's bracket -7, and this graph goes all the way up without stopping toward infinity. Then we get to the part about where are you increasing or decreasing. So as you talk about, or if you talk about increasing or decreasing, it's as you move from left to right. And you see that as I trace my finger along here, I'm going down until I get to this vertex, and then I start going up. And so that's the difference between where your function is decreasing versus where your function is increasing. Okay, so as you go from left to right, you're going down, and then this guy goes up. So intervals over which the function is increasing. So we'll say this. We're increasing on the interval. Now this is a part of your domain. So you are increasing starting right here at a value of -5. So it's going to be open parentheses because we're talking about open intervals here. And that's from -5 to infinity. So when you look at that part of your domain, from -5 to infinity, our graph is increasing. It's going up. Well, where is it decreasing? Well, it's decreasing on the left half here. So as you go from left to right, you're decreasing. And so you're decreasing on the part of your domain that's from -infinity down to -5. Now here's the neat thing about this. At -5, you are neither increasing nor are you decreasing. This is just the lowest you get. And at that point, he's not going up, he's not going down, he's just there at the bottom. So you are decreasing on -infinity to -5, and then you're increasing -5 to infinity. And that's all we have to do for that one. Let's try another one. Suppose we have f of x equals -3/5 quantity x minus 9 to the 5th power minus 2. So let's go ahead and start with what we know, right? This is a polynomial function, and we know for every polynomial function, your domain is going to be all real numbers. So we can go ahead and write that free points, right? Every time, free points. As long as it's a polynomial function, the domain is going to be all real numbers. Well, what about the range? Maybe we should draw a picture. So off to the side, let's see what we have here. So this is a polynomial function of degree 5, which means it's going to take on the shape of an odd degree polynomial. And those guys are typically your snake or your cactus functions that look like this, right? But since this has a negative, that negative is going to take your cactus and turn it upside down. So this is how it's going to be oriented. It's going to be shifted to the right 9 and down 2 units. So it's going to start right here. And instead of going up to the right, it's going to be going down on the right and it's going to be curving up on the left. Now this is not an exact shape, but an exact representation of the function, but it gives us a good idea about what's going on so that we can answer the rest of these questions. So the domain is all real numbers. The range, as you go from bottom to top, your range is going to be everything. This guy goes all the way down, he goes all the way up, and there are no breaks. It's not like the last problem. So the last problem went down and then it went up, and so it bottomed out right there. But for this one, it doesn't turn away. It just goes from top to bottom, bottom to top, so it includes everything. Well, where are we increasing? So again, when we talk about increasing, that means as we go from left to right, where are we going up? Versus decreasing, which is where we're going down. So as I trace along here, from left to right, I'm going down. I'm going down the whole way. So this guy's decreasing the whole way, which means he's increasing. He's increasing nowhere. Because he's decreasing on or over your entire domain. So for the whole domain, this function is decreasing. And you might say, what about right here? Well, he's going down, but he never turns back up. He keeps getting lower and lower and lower as you go from left to right. Okay? So we're not really talking about accurate graphs here. We're talking about a sketch, about an idea about what things are supposed to look like. That way we can answer these questions about the domain and the range, and we can get a good idea about where we're increasing or decreasing. It doesn't matter exactly what these values are. What matters is the shape. And so we know how it connects to things that are odd degreed, just like this last one. It had an even degree, so we knew it was going to look like a U shape. So use those pictures, draw a sketch, so you can quickly answer these questions.